multiplexers, transponders, and muxponders. All of these are very frequently used in optical networks. But what is the difference between them? If you want to find out more, stick around and we'll check it out. So let's start off with optical multiplexing. And simply put, what optical multiplexing does is it combines different optical signals onto a fiber, and on the other side it separates or demultiplexes those signals again. And in order for this to work, we need to have different wavelengths for each individual signal. And we can't just have any wavelengths. These wavelengths need to be within a WDM grid. So in other words, as an example, we've got CWDM or DWDM. Now, depending on the number of channels we're combining, we use different technologies. So this 40-channel DWDM multiplexer, for example, uses an arrayed waveguide grating, or short AWG. If we're talking about a smaller channel count, so for example this 4-channel multiplexer, then we're using thin film filters, or short TFF. But the important thing to know about optical multiplexing is that it is completely passive, hence passive optical multiplexing. And the other very important thing is, since the multiplexing is happening in the optical domain, the multiplexers don't care about data rate or protocol. So in other words, optical multiplexing is also ideally suited if you are combining different signals with different data rates or different protocols, because they don't care. So that's the optical multiplexing. Now let's get to the transponding. Now, transponding originally came about to convert grey optical signals to colored optical signals. So in other words, to make it possible to to multiplex these signals. And that is still the case today, but nowadays transponders are used for many, many more different applications. And to understand which applications they are, let's have a look at this admittedly extremely simplified diagram of a transponder. So what we've got here is we've got the optical signal coming in here in the client port. Here it is converted to an electrical signal. It goes through a clock data recovery chip, and then on the other side it is converted from electrical to optical. Now this optical to electrical and electrical to optical conversion is done with transceivers. So in other words, we could also say that a transponder basically is just connecting two transceivers back to back with a clock data recovery chip in the middle. And since we nowadays have such a broad variety of different transceivers, well, that is then where this new field of application comes to. So in other words, if we take, for example, this Cubo Mini 100 gig transponder module, where we've got exactly those two QSFP ports connected back to back with that clock data recovery chip in the middle, well then you can see here we've got a whole range of different applications. If you plug into the one side a single mode transceiver, on the other side a multi-mode transceiver, well, in that case we've got a very simplistic media converter between single mode and multi-mode. We can also use it as a midway repeater, or we plug in a shorter range transceiver on the one side and a QSFP28ZR coherent transceiver on the other side. Also, a transponder, or this Cubo Mini, is a very cost-effective demarcation device at a customer premise for service delivery. Okay, now that's the transponding. Now let's talk about the muxponding. And muxponding, just like transponding, takes optical signals, converts them to electrical, does something in the middle with it, and then converts the electrical to optical. And this electrical to optical and vice versa conversion is happening with transceivers. But here's the big difference. With a muxponder, we have got multiple lower data rate ports here, and then with a cross-connect and a digital signal processing, or short DSP, these individual lower data rates are then remapped or combined into a higher data rate port. So in other words, here we've got our 400 gig muxponder, meaning that we've got 4 QSFP 2800 gig ports, and these are then combined onto that individual QSFP DD 400 gig port. And the great advantage here is now we're talking about 400 gig QSFP DD, meaning we've got the whole range of coherent transceivers here. So in other words, we can reach much greater distances than we can do with the 100 gig coherent transceiver. Now, of course, with these different technologies, there is never that one fits all. And it very much depends on your individual application, which of these technologies is better suited. But these are basically the different technologies. So one of these will be the ideal suit for your application. So I hope this Brain Snack video clarified the difference between these different technologies. If so, please leave a comment. And of course, if you also have any additional questions or want to add to the topic, please also don't hesitate to comment. And last but not least, remember to follow our channel so you get your regular dose of Brain Snack. Until next time, bye-bye.